So picking up where we left off yesterday, we are going to find one more value, or we're going to solve one more problem where we have to find multiple values for theta when we're given a trig function of theta, but we don't know what theta is. And that did not come out right, but we're just going to push past that error that I just made. Okay, so let's take a look at this. If cosecant of theta is positive, that's important, it's a positive 2.3179, and theta is between 0 and 2 pi, so that's a positive rotation, one full revolution. Find theta. I would think find all values of theta to the nearest thousandth of a radian. So let's remind me, where is cosecant of theta? In which quadrants is cosecant of theta positive? In 1 and 2, right? Because everybody's positive in quadrant 1 and sine is positive in quadrant 2, so its reciprocal cosecant is also positive in quadrant 2. So here's what I know. We have a positive cosecant here and a positive cosecant here in quadrant 2. So there's two angles in a positive rotation where I'll get a positive cosecant. But the calculator won't give me both answers. The calculator will only give me one. Where does the calculator provide me solutions for sine? Not in quadrant 1 and 2, because in quadrant 1 and 2, cosecant's only ever positive. I need a negative answers too. So here is where the calculator will give me solutions. So in quadrants 1 and 2. So where are my two things overlapping? Where cosecant is positive and where the calculator is giving me a solution? In quadrant 1. Okay. So what's nice about when the calculator gives me solutions in quadrant 1 is that it also provides me with the reference angle, and I don't have to find it, because all the angles in a positive rotation that are in quadrant 1 are acute, and they're positive, therefore reference angles. So how are we going to determine, oh, well, let me go over here. We're also going to find this value right here, but we'll need the reference angle to find this one. So we're looking for these two values right now. Let's start with, how are we going to determine theta? Our calculator doesn't have cosecant, right? It only has its reciprocal function sine. So could I say this? The sine of theta is equal to 1 over 2.3179, right? And then after we convert it from cosecant to its reciprocal function sine, then we can take the sine inverse. So theta is equal to sine inverse of 1 over 2.3179. A common mistake, well, someone will take the sine inverse, they'll do 1 over sine inverse of 2.3. Calculator will tell you that doesn't exist. Okay, so it's really important that before you take the inverse function, you rewrite cosecant as a sine. All right, so what do we get? In radians, I'll give you a moment to plug that in your calculator. I'm waiting. I know it's point. All right, to the nearest 10,000th, 0.446. Okay, so if I come over here, this is the measure in quadrant 1, which is what the calculator is giving me an answer for, of 0.446. So what is theta's reference? Theta's reference is acute. Yeah, it's the same. If the calculator gives me a solution in quadrant 1, it's also representing the reference angle. So this measure over here on this side is also 0.446. And that's from the terminal side of angle theta connected to the nearest x-axis, which is really important. Okay, so here we go. In quadrant 1, we know the first value of theta to the nearest thousandth is 0.446. Now in quadrant 2, we're going to have to do some calculations. This calculator won't give us an obtuse angle for cosecant. So what are we going to do to find theta? pi minus, because it's not quite a full revolution of pi, right? But it's a little bit. So here's your x-axis. The closest x-axis is pi radians, and you're going to subtract 0.446, and that will give you the measure of angle theta. 2.696. So 2.696 then, because you have to go to the nearest 1,000. So if I were to just come over here and draw two little representations of both of these angles, one angle would be here at a positive rotation in our interval of 0 to 2 pi. And then the second angle that we found is the measure from 0 to 2 pi is in quadrant 2, and that measure is 2.696 radians. So we found both of the values, but let's just verify with our calculator. So we'll do a calculator verification or a calculator check. How do I know I'm right? Going to plug in theta, don't you think? That's what I should do. 0.446 and 2.696. So I'm doing, well, the cosecant of 0.446, well, that's a problem. I can't plug it in the calculator, so what am I going to plug in? 1 over sine of 0.446. Good job. So check that. Let's make sure we get something that's really close to 2.3179. 2.318? Oh, that's close enough, right? Because 79, that would round to 8.8, right? 0.2318. All right. And then we would also do 1 over sine. If you don't mind, I'm not going to write out cosecant first. We've got the process down. 2.32. Close enough. Because we estimated our answer, our interim answer, it's going to throw our final answer off a little bit. So definitely true in that case too. So now let's write our solution out by restating the question. In the interval 0 degrees. No, not degrees. Wrong problem. 0 to 2 pi open cosecant of theta equals 2.3179 when theta equals approximately 0.446 and 2.696. And so just remember, when you're doing your assignment, which is on Canvas, 8.3c, you're going to do numbers 35. PS 35 is in degrees, so make sure your calculator's in the right mode, and 37. And 37 is in radians. And there's 6 problems for each, 6 parts to the problem. So you'll do 12 of these, which is really important. Here's why. On the test, 2 free responses, 1 in radian and 1 in degrees, just like this, like 12% of your test. Okay, so important. Remember that you're looking for 2 answers for theta in a complete revolution. So sometimes it'll be really important to find that reference angle. Well, it'll always be useful to find the reference angle, so make sure you're looking for that. Okay, and I am not requiring you to draw pictures if you don't need to draw pictures. I am not requiring you to check your work if you don't want to check your work, not for your homework. But I am requiring you to write the solution in a complete statement. Okay, so those are my expectations. The key for this assignment is already loaded to Canvas as well. So if you're stuck on a problem, you can go look at my work. I showed all of my work. Okay, and I'll be available for the remainder of the period, the next 40 minutes, to help you, sit alongside you if you need help. Okay, so there we go. Off you go.